You may remember from your previous math classes that complementary angles add up to 90 degrees, or pi over 2 radians. That supplementary angles add up to 180 degrees, or pi radians. Now, you haven't really talked about negative angles before, so it's important to note that for complement and supplement, according to the definitions of complement and supplement, both angles must be positive. So, for example, the angle 145 degrees, well, the supplement of that angle is just 180 minus 145, which is 35 degrees. And even though 145 plus negative 55 will get you 90, we say that this angle does not have a complement because the definitions of complement and supplement indicate that both those angles need to be positive. Right? So finding complements and supplements is a simple matter of subtracting. If I want to find, say we've got pi over 12. Well, to find the complement, it's whatever adds up to pi over 2. So I take pi over 2 minus pi over 12. Well, pi over 2 would be 6 pi over 12. So the complement of pi over 12 is 5 pi over 12. For the supplement, supplementary angles add up to pi. So I take pi minus pi over 12. Well, pi is 12 pi over 12. So if I subtract pi over 12, I get 11 pi over 12. So, finding complements and supplements is a simple matter of subtracting. But even though, keep in mind that those angles do have to be positive. So angles that are greater than 90 degrees, or pi over 2, do not have complements, and angles that are greater than 180 degrees, or pi radians, do not have supplements. We can use radian measurements for a few different applications. One of these is arc length. Arc length is the length of, well, an arc of a circle that is cut out by a particular angle. So the arc length is just this distance around here. Now, we already know the circumference of a circle is 2 pi r. You learned that many years ago. The reason that it's 2 pi times r is because 2 pi is the angle that is in one full circle. If we have a smaller angle, theta, the arc length, which is called s, for reasons that I do not know, might have something to do with the Latin word for it, just like circumference is 2 pi times r, the arc length s is just that radius times whatever angle, whatever this central angle is. And this theta must be in radians. So if we just take an example, let's say we have a circle with radius 5 centimeters, and we want to know the length of an arc determined by a 20-degree central angle. Well, then we just plug into our formula. Our arc length is equal to the radius, 5 centimeters, times our theta, but we need our theta to be in radians. So we take our 20 degrees times pi over 180. 20 over 180 is 2 over 18, which is 1 over 9. And so we plug in pi over 9. And I'm perfectly fine with you just saying that our arc length is 5 pi over 9 centimeters. Right? You don't need to, I guess if the book says round your answer to whatever, you can punch that into your calculator and get a value. But on a test or quiz, I'm fine with you leaving it your answer in terms of pi. It's just applying that formula. We could go the other way. In the same circle, what angle determines an arc with length 6 pi centimeters? Well, that's just going the other direction. S is our arc length, so we plug in 6 pi for S. We know our radius is 5 centimeters, and we don't know what theta is, but our theta then is 6 pi over 5 radians. Another formula that uses radian measurements is the area of a sector. So you got this angle, and this kind of pie slice is called a sector. That's the math definition for it. And a sector has an area of 1/2 r squared theta. We know the area of a circle is pi r squared theta, or pi, yeah, it's just pi r squared. If we plugged in 2 pi for theta, that would be a full circle, and then 2 pi times 1/2 gets us just pi r squared, and that's the area of a circle. So that's good. We know that it works for a full circle. So let's say we have a same circle of radius 5 centimeters, and we want to find the area of a sector determined by an angle of 45 degrees. Well, 45 degrees, remember that's one of the angles I want you to memorize. That is pi over 4 radians. So the area of that sector is 1/2 times 5 squared times pi over 4. 5 squared is 25, so that comes out to 25 pi over 8. And since it is an area, that would be in centimeters squared. If I said we have the same circle, and the area of our sector is 9 pi over 2 centimeters squared, and I want to find what our angle is, then again, we're just plugging it into our formula. 9 pi over 2 equals 1/2 5 squared times theta. 2's cancel out. So our theta is just 9 pi over 25 radians. And that's how to find the area of a sector. Right? That's really all for today. This section is pretty simple, and maybe the next section will be too, but we'll be getting into some new stuff before too long, and it's really important that you know how to use radians and where radian angles are. So please do take the time to memorize those angles I told you to memorize. We'll have a quiz next class where I'm going to give you a short amount of time to write in radian and degree equivalencies of those angles. So I'll give you, say, pi over 4, and you'll need to know that that's 45 degrees. Or I'll give you 270 degrees. You'll need to know that's 3 pi over 2. And I'm only going to give you a minute or two to do these because I want you to take the time to memorize them. So please do that and be prepared for that little quiz next class.